Okay, everybody. So I'm going to talk a bit about some native mount points on Linux. So to start off, sorry if this is not too legible. I'll tell you what's on this. So when you have a single mount point in AFS, things are pretty simple. Here we just fs make mount point 1 for a volume called root.cell. And when you do that, of course, we present it as just a regular directory. So it looks like a directory. You can cd into it, you can cd out. It's pretty much exactly the same as a normal directory. But if you have multiple mount points, things get a little more complicated. So in this example, we're making a mount point called mount point 1 for root.cell, and we make a second mount point in a subdirectory, so dir mount point 2 for root.cell. And if you cd into mount point 1, you can cd back out, you cd ... you go to your parent directory, and if you cd into dir mount point 2, you cd ... and you go back to the parent directory of that. So the question in this case that makes things kind of weird is what is ... which directory does that refer to? For both of these mount points, the mount points refer to the root directory of that volume, so they're the same directory. They have the same contents, the same metadata, like they're the same underlying object. You don't have two different objects. That's true in Linux and in most operating systems just in general. That's how we work. There's one vcache for that and one vnode on the server. So for Linux specifically, it helps to understand how the BFS is laid out a little bit. We have these structures called D-entries, which means directory entries, and inodes. Roughly speaking, an inode just refers to an underlying file. A D-entry refers to a link to that file, the directory entry for it. So when you make hard links, you're used to making hard links for files, that adds a new D-entry for it, but both of the links refer to the same underlying inode. But you're not allowed to do that for directories. And when anybody starts looking into this, you might ask why. Usually the quick answer given is that it's very easy to create directory loops when you do that. If you're in a directory and you make a hard link to a directory above you, then you can keep descending into the directories infinitely, and it's kind of hard to detect the loops, at least hard to do that efficiently. In Linux, not only can you not create hard links for directories, you're not really supposed to make D-entries, multiple D-entries for the same directory inode. Historically, we have done that. We did it anyway, and it causes problems over various Linux kernel releases. Sometimes they're kind of subtle, sometimes they're more obvious. And on other platforms, and I think sometimes on Linux, the answer to that question before of what ... refers to changes on access. So it can actually change very frequently. So if you access through mount point 1, ... refers to the parent directory of mount point 1. And then later on, when it's accessed through mount point 2, the ... refers to the parent directory of mount point 2. And depending on how the access patterns go, that can be very confusing, and some people would say wrong. Now, there are some special cases in the Linux BFS in the proc file system. So I said there's no hard links to directories. There's no D-entries for the same inode. But these files, so proc pid cwd, proc pid fd, look at the file descriptors, they look like symlinks, but they're not normal symlinks. They're obviously not regular. Like a normal symlink is just a string that refers to a path, and then you look up that path when you dereference the symlink. But if here we're just making a process that the working directory for that process is some directory, we delete the directory, and you can see in proc it refers to a directory that is deleted, but you can still access it. You can access it through the cwd and the other files in proc, and you can still, you can go in there, you can create files. If you create a new directory with that same name, they're obviously still two different files. So it's not a symlink, it's not a hard link. You might wonder what is actually going on here. So in Linux, there are, depending on which version of the kernel you're talking about, there are some callbacks that we can implement for a file. Follow link is usually used for symlinks, but because it doesn't just return a string, you can return a reference, like just a machine reference to a specific file, and that's what the files in proc typically do. there's another one called d_automount, which is supposed to be used for automatic mounting of things. We use it currently as a kind of like a way to kind of teleport what file we're referring to when you dereference it, which is not what it's intended for, but it does work well enough to actually make our mount points work. That commit that I referenced there, Garrett 7741, that was how that's kind of what put into place our current method of working around this. There's been a few changes since then, but that's the general approach for modern Linux versions. So this makes if you have multiple mount points like that situation that we showed before, we try to make them act like those entries in /proc, which still is not what some things expect. In particular, some versions of find, more modern versions of find, when they traverse a directory structure, it doesn't keep track of where we are in the tree. So when it goes into subdirectories, and when it goes back up, it tries to cd into ... So it doesn't just look at the last component and strip it off. We try to go into ... to get us back up to the parent directory. So if you have a directory structure like that, where you have one mount point with a subdirectory and another mount point inside there that refers to the same volume, you can get that order of traversal for those files. So find can look at mount.1, then the subdir, then mount.2, and then it tries to go back up one directory, but it actually goes up the whole thing. So that can make it so you skip all of the other entries in mount.1 after subdir. So it will never see them, and it won't notice, and it doesn't print out any warnings or anything like that. So we still have that problem. Obviously, there's got to be a better way to do this. We've been trying to work around things, do some hacky stuff, but at some point we were going to have to do something better to get rid of all these problems. So in the Linux VFS, of course, the way we're supposed to be doing this is we're supposed to be using mounts, actual mount points, not AFS mount points, the ones that Linux actually recognizes. There really is no way to have multiple places with the same directory to exist in the tree. If you ask anybody, if you complain about a bug that happens when you do that, the kernel devs just tell you it's a bug that we're doing that at all. So that's really the only way to do it. Fortunately, our model fits that scheme very well. Obviously, we call them mount points anyway, so that's what they're supposed to be. Volumes are very easily seen as devices. They can be seen as different partition devices, that kind of thing. And when you want to access them, you could just have a mount point that refers to that volume. So since this gets rid of all these problems, it seems very intuitive. Why don't we already do that? And the short answer to that is of licensing issues. In user space, you can create a new mount very easily by using the mount command or the mount syscalls or anything like that. Anybody can call those. Those are all very well understood. If you're inside the kernel, you're supposed to use this function called VFS kernmount on modern kernels, but we're not allowed to call it because it's only supposed to be used by GPL compatible code. And that's how things like the entry AFS implementation work. So some ways to get around that include creating a new module, which is GPL compatible, just a shim that just calls that function. Some other modules have done stuff like that, like ZFS on Linux, I think, has a layer that it goes through. Obviously, some people don't like that. It's kind of sketchy on if we're really allowed to do that. We could implement our entire client in Fuse, so more of our code would be in user space, so issuing the mounts is a lot easier. We could also just have everybody try to use KAFS instead of OpenAFS, which, I mean, we're fine with. If people want to, I'm always open to that possibility. It doesn't really serve everybody's purposes as it exists right now, at least as it exists in Red Hat releases. But that can always change, that can always improve. And the last thing there is we can issue the mount syscall from user space by going through a user space upcall. So the kernel causes one of our background daemons, it sends a request to a daemon that's running, and that daemon runs whatever user space code that we want to run. So that already exists. We have a framework for that because we need to be in user space to issue, well, we don't have to, but it's obviously a lot easier to make DNS requests in user space. So for DNS and AFSDB support, we already do that. And for Mac OS X, there's a user space thing to help you move files between volumes because of some quirks on how Finder works. So I've implemented that, the user space upcall thing. So this is just a quick example of what that looks like when you use it. So if you cd into /AFS into a cell, into a volume, then these submounts are mounted automatically, and you can see them in the mount table. So here we see some regular ones, and then at the last two entries there show the volume name, or it's formatted kind of like a well, it's formatted exactly like the Mountpoints string inside AFS. So it tells you what volume it is, where it's mounted, and obviously that it's type AFS. However, in the current implementation, they don't show up as separate underlying devices, so you don't see them in DF. You don't see things like per volume space usage or quotas or whatnot. You are also allowed to issue the mount yourself. The interface for this is not particularly friendly right now because it's really intended just to be used by our code automatically to automatically mount things for you. But technically, like, we don't check or anything like that, so it is possible to do. The string that you give the device name, in that example, it's root.cell, we actually don't really use for anything. We just print that out in the mount table so you can identify what things are for. We don't look up the actual volume name. You just need to actually specify the numeric volume ID in the mount options. It's just a little quicker that way because when we do the automatic mounts, we've already done the lookup. We know the volume exists, and so we know its ID. In that example, I show mounting it at I mount the root.cell at some other location, and that's just me showing that they are the same, like they're the same file. You can see the device and inode are the same. So showing that example, it does minimally work, at least. There are still some concerns with this approach. The first one there is how we deal with cleaning up these mounts over time. So if you access 1,000 volumes and then you don't touch them ever again, if we don't unmount things, then those files will stay in the memory cache and sort of in our disk cache. They'll never go away on their own. Somebody has to unmount them. Since we mounted them automatically, we need to unmount them automatically. So the current approach for doing that is every, I think it's 5 minutes or so, we just go through all the mounts and try to unmount them with this flag called mount expire. And this can be used to unmount things that are just not, haven't been touched. So if it hasn't been touched since the last time we called unmount with mount expire, it'll get unmounted. And if it is still in use, then we'll just get an error. So that's not terribly efficient because right now it's just a flat list of everything we've mounted, and every 5 minutes we try every single one. The in-kernel mounting mechanism has a better way of doing this. They have more control over that, so they know that you don't have to try every single one. You just know which ones, as they get no references. We just keep track of that as it goes. And if we had the in-kernel facility, we wouldn't need to do this at all. Like Blanks just handles it for you. Another concern is what happens when you have that many mounts. Many places will have clients that access, thousands, tens of thousands, hundreds of thousands of volumes in a very quick amount of time. And I don't exactly know what happens with performance in the mount table when that happens. I just haven't really tried. I'm assuming there are places that do run Linux with that many mounts and it's fine, but I never know what the effects are. I believe like mount stuff in Linux is stored kind of all in one big hash table, at least in the versions I remember looking at. But of course, if that's a problem, it's always fixable, just not by us.
Yeah, I've heard people that have 10,000 NFS mounts.
Yeah. I think also in those cases, I'm not sure if they're hitting them all the time. Like it would be like 10,000, but it would be like 10,000 different ones in a directory. I don't know how nested they are. Because in these code paths, you'd be, if you go AFS cell vol, you're hitting every single mount path like along that. that path, and that might be like slower than the normal RCU lookup. I'm not sure. And of course, the concern is that we need testing for it. This is just something I have done as an experiment to see if it would work, and it's been working so far. So we kind of just keep going until something breaks. This is us trying to do things kind of proactively instead of waiting for something to break in the Linux kernel and then we scramble and try to fix it as quickly as we can. We're trying to get a little ahead of this, so this wasn't like most of the things that I do and that SNA does tend to be based on a customer need specifically. So we have a customer that's running things and giving us feedback. Here we don't really have that. I was just kind of trying it. So if it is interesting, I'm sure we'd be very happy if anybody would like to run it in a testing capacity. So for future directions in this feature, right now the way we implement this is kind of quick and dirty. So the reason we don't see separate devices in DF is because the mounts themselves, the way they're implemented is that we do an internal lookup of that path, which don't go through the, we don't do auto mounts for those vnodes, those types of files. And we use that as the root D entry for that mount. So we don't create separate superblocks or anything like that. I don't think it's terribly difficult to do that. I haven't looked into it yet. Just wanted to see if this would work at all. And that approach has the very obvious problem that it doesn't work with non/AFS mount points. We don't have any way right now of seeing what you actually used for /AFS. The AFSD does not tell the kernel, it just does the mount itself. We could add something to do that, but it's better to just use real mounts with separate devices. That would make things a lot easier to deal with. And once we get separate devices, you could actually look at volume usage according to each volume. So you could run df-h and you could see the volumes. You could run df-h dot and see in your current directory how much space you're using, how much space you have. So it wouldn't need to be a AFS specific command. Other tools would actually be aware of space usage in AFS, which would be pretty nice. So if you want to run this is submitted to Garrett. That first link, 13285, will give you all of the code in it. That's the top commit. So you can run it from there. There are a few different commits, and they're in that Garrett topic. And we are maybe planning for this to be in 1.9. I don't know if that's a possibility or not.
It's a possibility.
It's a possibility. Yeah, I didn't mention it here. It is off by default. You have to give AFSD a flag to turn it on.
Oh, yes.
So it is. It's not always on. It is a separate code path. Like I didn't replace all of the mounting logic with this. It is a separate thing. And if you want slides, they are up there. I think they're up there now. if you want to look at the actual slides.
And if it's not in 1.9.0, it might be in 1.9.1.
Yes. Yes, that's always a possibility, and it will be. I'm sure it will be rough in those. So it will be as a testing capacity. Yeah. Any questions or comments or anything else? Yes, Yadav.
So since you're having a single super block for all the mount points, can I assume that they work similar to the bind mounts, where every mount will have a different DFS mount structure referring to the same directory?
Yes. So I'm repeating questions just because I don't know if the mic can pick this up. So Yadav is asking about since we use the same super block, if these behave similarly to bind mounts, basically is what you're saying. Yeah, so it's basically the same thing. It's basically a bind mount. It's just a little easy. So in an earlier version of this, it was actually using literal bind mounts. Like the command, I ran the command mount -- bind from that location, from the mount location to the special :mount path. I guess I haven't looked into too much of the details, but I assume the code path, the Linux handling for it is pretty much the same. Because we look up that path and we just give it the D entry for the root, and so it creates a separate VFS mount, and the root just refers to that D entry instead of the original root D entry. So the super block is the same, but the root D entry is just different.
And do we support the mount options also, like read-only and all such options?
Yeah, so Yadav is asking about if we would support other mount options like read-only or like no exec, things like that. This does not. I haven't looked into what is involved with with doing that, that seems like something to do at the same time when we have separate devices. Yeah, that's probably when I would do that. And yeah, that certainly makes a lot of sense, and that would probably be really helpful too.
Yeah, because I think those would be some of the flags that you pass to SES.
Well, yeah, actually, I don't know if there's like a common parsing. You can definitely do. I know what the code path looks like for doing the parsing yourself. I don't know if do other file systems just pass the string to handle like the common options? Because I imagine not, because they have to have their own flags and their own structure. So. But the parsing, Linux does provide parsing facilities, which are very easy to use. Yeah, I use it for this because we have options. So we already use options. It's just you got to put in the ones that actually that people are used to, like no exec and read only and all that. So yeah, that's a good suggestion. We should do that.
So the default internal way that volumes are mounted inside the cache manager, not this method, but the default way, is if a volume has read-only copies, read-only clones, then it's going to be mounted as read-only, and then the user can't actually modify it.
Yes.
So is it just looking at your mount command there, that you have the mount-t AFS, and you specify all the arguments. Are you providing a way to explicitly specify the read-write volume ID that you can technically get around that limitation?
Okay, so Paul's asking about yeah, I'm not sure how to concisely say what you said. But he's asking about the read-write versus read-only logic, basically. So what you're talking about is, it sounds like you're relying on that to prevent users from ever hitting the read-write space.
Yes.
I don't think right now it's like you can still access the read-write if you know how. You can that path like this allows you to access any volume if you know the ID, which I believe is always on Linux because it was added in some commit for the translator and we need to have it on.
I'm not familiar with that first line.
Yeah, so this is a
Well, if you don't have binary at all,
there's a code path for non-binary for adding it in there. So this is a your AFS is not mounted at /AFS, but just the root directory, whatever it's mounted at, the default is /AFS. There's a magic directory under there called :.mount, which allows you to access file. It's either volumes or the logic for accessing individual vnodes may not always be on or something, but there's that is in place. It's possible it's not on for every kernel or for maybe it's not always there. I don't know. I thought it was always there for Linux, but that allows you that allows anybody to access a specific volume. So the way the mount also the mount command that I issued to do that can only be run by root. So regular users would not be able to bypass it that way.
If you didn't have the timer on, I could create a mount point in a directory that I have access to.
You do have to have admin access somewhere, but yeah. So if a user had their home directory, for instance, and they had admin access there, they could make a mount point to the read-write directly if they wanted to. And just to explain, I don't think this is what you're asking about, but just to explain that kind of logic of picking read-onlys versus read-writes, we have some logic whether you cross cells and all that stuff, all that is the same. The mount command, that's why we do the resolution from volume name to volume ID before we do any of this stuff. So that's why it passes the explicit volume ID to the mount command. Hold on, do you want to?
Just one follow-up. I mean, just again on that top line there, maybe that's a feature that is not visible. Is the : mount, will that always be visible at the top level?
No, if you list the directory, I don't think it shows up. Okay. You have to specifically access it, I think.
Listed.
Okay.
Well, you can if dinroot has it listed. I thought for regular directories, it's only caught if it's explicitly looked up. I thought.
Nice.
Yeah, we can talk more about this in detail if we want to. If this is a concern. That's not my. That's not the area I was looking at too much into detail for this talk. Yeah, Yadav?
If you write any test case where the root volume, that the root of your test is having a multiple mountpoints, you try that test case with this patch.
With this patch, no. That is, yeah, so usually I run with dinroot, so I haven't, but even with dinroot, you could probably do that. Yeah, Yadav was asking about if we add a mount point in the tree for root.afs, what happens with this patch? So what I expect will happen is that it will, so I think what you're getting at is that that's a way to create multiple de-entry aliases to the same volume. I don't know if that's why you're asking that, but that case, that does, yeah, that's true. That does create a multiple de-entry aliases. I probably would need to add a specific check for that where we would just use the same, the root de-entry instead of looking up the colon mount thing. So that's probably how we'd get around that, but we'd have to add it. I don't think I added that.
I've seen some references where that will happen. Where specifically for the root entry.
Oh, okay.
So I was just curious whether matches having that scenario.
Okay, I was not aware of that. We are aware of some other cases where you can get deadlocks, things like if you have a, there's a commit where I refer to them as immediately recursive mount points, where if you have a, if you have a volume and you create a mount point for it inside, like as the first level thing inside that volume, and you try to like move something from from like the parent directory to inside that, there's some edge cases there. So in the, after, what was it, for like that commit, I think, or something around that time period, added some cases where we know it's possible to deadlock, so we return an error in those cases. So adding that commit actually made some specific directory structures like you can't use them, but the only alternative was to deadlock. So there are some layouts of mount points and directories which just return errors immediately. So it's possible there's always there's more we need to check, and of course having real devices kind of gets rid of all that, because that's why we should, yeah, so I said I could add a special case for that. I probably shouldn't do that. I should just work on getting them to work with different super blocks. That would work a lot better.
What was Yadav's, I didn't understand the question.
Apparently, well, there's some cases, apparently, where we can have deadlocks if you create a mount to root.afs and do some action.
And the reason is we handle this scenario for other volumes. So then we are code. Is particularly special. There is a global variable like
yeah.
FS is global. So we cache it, and in most of the cases we don't do heavy checks for the global cache. There's global cache. So we are showing that case.
Yeah.
So it's pretty assembly thing on twice.
Yeah, so it's just like if you create a mount point to root.afs, just like any other volume.
Oh.
You can even probably mount something for the dinroot. I'm not sure how you would do that, but it's probably possible to make that happen. Because if you give the numeric IDs and you know what they are. So I was not really aware of that. That would be another problem to solve.
The scenario that Yadav was talking about is we had one cell that, when you have root.afs and it's mounted as AFS, then you have the root.cell mounted on there. If you need to make changes to root.cell, you have to mount root.afs, read write to get into it to be able to make the changes, to make the new mount points for anything else that's going on there.
Right.
But we had one site that never, once you were done with that, then you would remove the mount point to the root.afs read write. Well, this cell left that there all the time.
Mm-hmm.
So they would have jobs that would either doing a find or doing something, and they would always find its way to get into that other mount to root.afs, and that's where they would get into the problems and doing some of the things. So as we debug it, that's what what we were running into. That special case.
Yeah, so in that case, the deadlock happens in like certain special accesses. It doesn't happen like when you just like as soon as you mount it or something like that. It's when you're doing stuff. Yeah.
They may have been doing a move and things like that, just fast work it.
Do you have a test case that can reproduce that?
Yeah, and that's an analysis also. So it's a soft blocker which happens in the DFS layer. So in the DFS layer, you just keep traversing, and that's when you get the soft blocker. The recursing, and that's when you get this.
Okay, so it's not necessarily a deadlock. It's just not giving up. It's not scheduling for a long time. Okay.
And the reason is that for the entry tree,
Yeah, you go by
you
parents.
have the root pointing to the parent. You should have the parent of the root pointing to the root itself. But in this case, it's pointing to the other thing. So you again go there, and then
Yeah, and then you go down. Yeah, so something checks if it's root to see if it's pointed at itself, but it's not pointed at itself here yet. Yeah, so that's one of the examples where the Linux devs would say stop creating multiple D entries to the same directory. Causes problems like that. Okay.
I also find something that one of the IT service plays, they call it better mousetrap FS. And so it creates like a fake directory entry /AFS/000-better mousetrap. And if any process tries to access that, it gets the
That's pretty fun. It's funny you say that because there's a very similar piece of functionality that's a customer's patch that we have written.
yeah, there are too many people that run find.
Yes. And we've been kind of talking about whether we should, that was kind of a it was a site local patch. We weren't planning to upstream, but if other people find that useful, perhaps we should be. I've been thinking maybe we should have that functionality in the upstream case and just have it be configurable so it's useful for other.
Seems pretty reasonable.
There's causes it to hang like forever until it's investigated.
They're protecting the entities. Yeah, we talked about killing it, but then we decided to
Something like here be dragged.